Hello, my name's Adam.
I'm Gabby, and this is TiVo.
And that's Gator. And today we're going to talk about math.
Enjoy the lesson.
Yeah. To start out, mean is the average of a set of values. But in this case, there's an extra step or two, and the mean may be called an expected value on the AP exam. It is the same thing with standard deviation. Typically, it is how much a set of values may vary from the mean on average. And there are two formulas for mean and standard deviation. For mean, the two formulas are mu of x plus y equals mu of x plus mu of y, and mu of x minus y equals mu of x minus mu of y. And then for standard deviation, it's sigma squared x plus y equals mu squared x plus mu squared y, and sigma squared x minus y equals mu squared x plus mu squared y. And the key differences between these formulas are that both standard deviations add even when they're subtracted from each other because they're squared. Mu is squared in variance equations, unlike mean equations. And square root answers from the variance equations to get the standard deviations. So you square root the answers from the variance equations to figure out what the standard deviation really is. And also there are PDTs. We implicate these formulas using tables called probability distribution tables, or also called PDTs. These tables show the probabilities associated with each possible value or outcome x. This is a PDT. It's vertical, not horizontal like it usually is, but here goes. The outcomes are listed here. Getting 0 pieces of candy, 1, 2, and 3 pieces of candy, and the chances they'll get in, let's say, a raffle. So the chances of getting 0 is 10%, the chances of getting 1 is 20, chances of 2, 30, and the chances of 3 is 40. Yeah.
Here's an AP practice question. Ohm sells phones for Apple. He also gets trade-ins for phones. Typically, Ohm sells one phone an hour and usually helps people with trade-ins, not once an hour as shown in the PDTs for each. Here's the phones Ohm sold in an hour.
So he usually sells 1 an hour, 51% of the time, 0 an hour, 31% of the time, 2 an hour, 17% of the time, and 3 an hour, 1% of the time, as shown with X outcomes and P the probability.
And here's the phones Ohm sold with trade-ins in an hour.
0 with no trade-ins, it's 52%. With 1 trade-in, it's 26% of the time. 2 is 17%. 3 is 5%. And again, the outcomes, the amount of phones he can sell in an hour can range from 0 to 3. And these are the probabilities for each outcome.
Part A, expected total sales and trade-ins in an hour. Part B, expected total sales and trade-ins in 3 hours. Part C, expected difference of the standard deviation of sales to trade-ins. And Part D, expected sum of the standard deviation of sales and trade-ins. Pause now if you want to do it yourself.
So to start out with Part A, the expected total sales and trade-ins in an hour, you always rewrite the formula, and then for U of X plus Y, U of X represents the sales and U of Y represents the trade-ins. To find U of X, you multiply the outcomes by their probabilities, and you do the same for the trade-ins as well, and then you add those two together to get your mean for trade-ins and sales per hour. So with Part B, the expected total sales over trade-ins in 3 hours, you do the formula, which this time, since it's total sales over trade-ins, you're going to use the subtraction formula for mu of x minus mu of y. And to find that, you do the same process by adding up the probabilities and outcomes, like multiplying them together. Add those up to get your values, but for mu of x and mu of y. But this time, you subtract those values. And because it's 3 hours, that difference you multiply by 3, since it's not just 1 hour. It's 3 hours ohm is working. So instead of 0.13, it would be 0.39 because it is 3 hours. So for C and D, you gotta remember that the standard deviation equals the square root of the variance, and to always keep your answer as a square root, especially if it has a decimal in it. So part C is expected difference of the standard deviation of sales to trade-ins. So you're going to want to start with your variance formula, which is mu squared x minus mu squared y, since it's a difference we're trying to find. But since it's being squared, you actually add them. So what you want to do, which is different from the means, you want to square your outcomes and then times them by their probabilities. And then after doing that for the sales and trade-ins, you add them together. And since variance is the squared version of standard deviation, you want to put it under a square root, as shown right here. So for part D, it's the expected sum of the standard deviation of sales and trade-ins. And just like part C, it's mu squared x plus mu squared y. And you do the same thing as C by squaring the outcomes and then timesing those by their probabilities. Add those up to find your variance, and then you square root that variance and keep it under the square root. So the reason C and D are the same answers is that the outcomes are squared, making them both positive. So that's why you add both the variances together. And then you get the answer after squaring the outcomes and then timesing the probabilities. You square root it to get the standard deviation. And the key takeaways of this video are to remember the differences between the mean and variance equations. Standard deviation is found by square rooting the sum of the variance equation, as I just said. When a number is put into a question for these types of problems, remember to multiply your answer, and it's most likely a problem dealing with means. And finally, PDTs, like in other topics and statistics, can be used in the real world.
Hope you enjoyed the video.